Hello and welcome to a new video. This is for pre-algebra using the Math You See curriculum. We are on lesson 8. If you'd like to go to my website and download a free notes page to use to follow along, the link is in the description or is possibly floating above my head. So let's check this out. Today we're talking about roots and radicals. Before we actually talk about roots and radicals though, let's talk about a thing called opposite operations. So in math, the very first thing we learned how to do, I guess if you don't count counting, maybe counting is the first thing we learned how to do. Then we learned how to add. Then after we learn how to add, we learn how to subtract. And those two things are opposites of each other. When you add things together, that's the opposite of subtracting them, right? So I can put in these first two blanks, addition and subtraction. Because whenever I'm thinking about addition and subtraction, I'm thinking, okay, these undo each other. If I have 5 plus 9, well, if I minus 9, then I'm undoing the plus 9 because they're opposite operations. So the same is true for the next two operations we learn about, multiplication and division. So multiplication and division are also opposite operations, because if you multiply two numbers together and you're like, well, wait, I want to go back to the first number, you could divide and that would get you back to the original number. This is actually going to be important for the thing we do after this as well, lesson 9. So, and just in general, it's important for algebra and for continuing on in math, so keep that in mind. We like to have opposite operations. So we have one for addition, we have one for subtraction, which is addition. We have one for multiplication, we have one for division. So last time we talked about exponents. What would be, if we think of exponents as an operation, that having a squared or a cubed or whatever it is, that is telling us to do something, which is what an operation is, then what's the opposite of that? How do we undo an exponent? Well, the answer to that is radicals. Or roots. So actually, these are two words that kind of mean similar things and are kind of used interchangeably. We are today going to talk about, specifically though, square roots. So we're specifically going to be focused on, if I have 5 squared, what is the opposite of that? How do I undo the squared that's a part of the 5 squared? The answer to that is square roots. So I would say that this symbol that you see here would be called a radical symbol. We could use the word radical to describe what's happening here, and we wouldn't be talking about radical as in, well, those are some far out ideas. We'd be saying radical as in this symbol. So one of those times where the normal meaning for the word, I don't know that that really makes sense in a math context here. So what we do is we call them square roots. We have this symbol that we use, and it's basically telling us to find the square root of whatever's underneath. So our problem might look like this down here, square root of 25. That's how we could read it, square root 25, or we could say radical 25. I think it's much more common to hear it as square root 25, but either of those is fine. The question we would be asking ourselves when we are asking square root of 25 is, what times what gives me 25 where I have the same answer both times? So it's not just anything that multiplies together to get 25. It's a very specific case where it has to be the same number twice. So in this case, that would be 5 times 5, right? 5 times 5 is 25. Therefore, the square root of 25 equals 5. Okay? So if you think about this, there's a lot of numbers that are not going to have square roots, or at least not going to have whole number square roots. Because of this, we actually really like the ones that have whole number square roots, like the number 25. Numbers that have whole number square roots are called perfect squares. So 25 is a perfect square. And really, in general today, as we look at these, we're going to be seeing almost all of these are going to be perfect squares, just because that's where we start when we start with square roots, is talking about perfect squares, because the alternative, when we talk about things that aren't perfect squares, gets a little complicated. Let's visualize this. So square roots are talking about something squared. That's the idea. So we could visualize square roots using unit blocks or blocks on a paper like this. We could look at this and say, okay, this has 3 on the side and 3 on this side, that's basically saying 3 times 3, or 3 squared, which is 9. So we're thinking backwards when we think square root. So the other way to think about this would be to say, okay, square root of 9 is 3, because I have 9, and then I'm thinking about the side links now, is kind of what square rooting does. I'm thinking about what would the sides have to be of this square if the area of it is 9. So the same kind of thing over here. This is a 10 by 10, so it would be 10 squared, which equals 100, which means that we can say that the square root of 100 is 10. So that's a way to kind of visualize what's happening with squares and square roots. Let's just do a whole bunch of square roots, partially because if you haven't thought about these numbers being perfect squares or having square roots before, might as well think about that now. There's only actually one number missing here from our multiplication tables, and that's 25. The square root of 25 is 5, which we already did kind of earlier, so that's why I didn't include it. So it says give the square root. So the idea here is they gave me 16. They're asking me what is the square root of 16. It might help us to go ahead and draw a square root symbol. This would be some good practice on drawing it. This is one of those things that you might feel like your square root signs look funny for a while, but as you do more of them, they should look more square root-like. So what is the square root of 16? So what times what gives us 16 with the added condition that it has to be the same number twice? Because there's lots of things, well, not a lot. There's more than one thing that multiplies to get 16. 1 and 16, 2 and 8, 4 and 4. Which of those is the same number twice? 4 and 4, right? So the square root of 16 is 4. Once we take the square root symbol is not there anymore. So that's our answer. By the way, the square root sign kind of looks like a long division sign. I don't know if you noticed that or not. I imagine there's a connection there, but I don't actually know 100%. But square rooting is kind of like having division. I don't know. All right, B, square root of 81. So what times what gives us 81 where it's the same number twice? And it may in fact be easier to think of this kind of the opposite way. If you're having trouble thinking of what multiplies to get 81, then you need to do more multiplication tables, by the way. But if you're having trouble with that, then no matter how long you think, you're probably not going to think of what it is. So another way of doing it would be to say, okay, well, what numbers squared do I know? 1 squared, 2 squared, 3 squared, and then keep thinking of those numbers squared until we get to 81. So if we do that, we'd see, okay, 9 times 9 is 81. So the square root of 81 is 9. I imagine that a lot of these are going to be either you know it or you don't. Like you either immediately can think of what times what gives us this number, or you're going to have to wait until I tell you. But if that's the case, that you're having to wait for me to tell you, this is something that you could memorize. This is something that you could just, once you see it, it just might make more sense to you. So just because you don't know the answer to whatever question I might be asking right off the bat, that's not necessarily a bad thing. Sometimes I don't ask questions as clearly as I would like. So just roll with it. So square root of 100 is 10, because 10 times 10 equals 100. D, the square root of 64. What times what gives me 64? So lots of things multiply together to get 64, but the thing that multiplies twice is 8. Square root of 1. What times what gives you 1? There's only one option here, 1 times 1. So our answer is 1. Square root of 49. And so again, this would be, if you don't know this one off the top of your head, this is a not familiar enough with multiplication tables issue. So square root of 49 is 7. Square root of 0 is, what times what equals 0? 0. Square root of 4 is 2. Square root of 121, that's a fairly big number, and as toward the end of the multiplication tables, I'm not even sure if everybody learns the multiplication tables up this far anymore. Back in my day we did. So square root of 121 is 11. 11 times 11 is 121. Square root of 9 is 3. Square root of 36. What times what is 36? That would be 6. Square root of 144, again, a big number. It's bigger than 121, so it has to be at least 11, right? And so think 12 times 12. Yep, that's 144. So there's our answer. Like I said, I did all the numbers from 0 to 12, other than 5, because we'd already done that one. So you could now, as you're practicing taking square roots, you could have this nearby to kind of help you when you get stuck. If you're looking at this constantly as you're trying to do problems, well, we could argue that you're not really doing them yourself. But it's better to look at this and try to move on, and then hopefully, like, you know, hopefully your brain will just be like, oh yeah, okay, I'm getting the hang of this. I didn't know what square root of 49 was a little bit ago, but I've done it enough times now that I know it's 7. So here's our square roots. This is one way that they can ask us. They asked us, give me the square root. They didn't put a square root symbol. They asked us, hey, what's the square root? Another way they can ask is to have the square root symbol there. So in example 2 here, the instructions say solve. That's another word for basically being like, do the thing. Okay, in this case, at least, that's what it means, is find the answer, which is both vague and also, in this case, I would argue kind of obvious what we're supposed to do. So we're going to solve each of these. The first two are going to be really similar to example 1, and then we're going to actually get into something that's a little bit trickier conceptually. One of the differences, though, is that it does have a square root symbol here for us instead of us having to write it down. So the square root of 64 is 8. That's it. That's all we have to do. So if there's 2 sections in the workbook for this. So if you finish the first one, turn the page and look at the next section, you might be like, wait, what's different? Because at first, at least, it seems exactly the same. And it is. So B, square root of 4 is, what times what gives us 4? The answer would be 2. Now we're going to change it up a little bit. What is the square root of 9 squared on C? There's a few different ways to think through this. You could think, well, I know what 9 squared is. 9 squared is 81. But wait, I know what the square root of 81 is. It's 9. So that's one way you can work through what the answer is. Now that you've seen that, especially, you may be like, oh, wait, I could have figured this out quicker, right? Because if the square root is asking me what times what gives me the thing underneath, what times what gives me 9 squared, the answer has to be 9. Right? So what I was doing on the previous example writing this, what times what equals 9 squared, that's like the definition of 9 squared, right? Is that it's 9 times 9. So we could go about it that way. The other way to go about it, and this is kind of a, once you realize this is true, sort of a situation, these are opposite operations. Square rooting a squared gets rid of both of those things. Just like whenever I add 5 to something and then subtract 5 right away after that, those cancel each other out. Well, guess what? That's what's happening here with the square root and the square. They're canceling each other out so that all we're left with is what's underneath, which is 9. Leaping into that way of thinking is going to help us once we're in algebra and once we maybe have x's or things like that. Or if you look ahead at E, we're already kind of seeing that here even in pre-algebra. Let's do D first though. Square root of 5 squared. So again, you could go ahead and change that to 25 and then find the answer, or you could think through, okay, what times what gives me 5 squared? Or you can think they undo each other, and my answer is 5. E, what is the square root of x squared? So we can't think of what x squared actually is because we don't know what x is. And this is where using a dot would be helpful for multiplication. But basically we're saying what times what gives me x squared, where it's the same thing twice. Well, it would have to be x times x, right? X times x would give us x squared. We're finding the square root of x squared. So our answer is x. I think if that's not making sense, this is one of those things that once you've done so much more math, you'll look back at this and be like, how did I not understand this at first? And so that's not to say that you should understand it right away. It's just that this is something that maybe needs to click. So if it's not clicking yet, think about it some more. Leave a comment. Send me a message if I'm actually your teacher, and hopefully we can make some progress here, because it's both a really challenging concept at the same time that it's not a challenging concept. It's weird. I don't know. Let's look at f. What is the square root of 3? This is a trick question because it's not a perfect square. 3 is not a perfect square. So I wanted to talk through some of our options for whenever we see something that doesn't have a square root. One option is to put it into our calculator. Our calculator will tell us that this is 1.74 with a whole bunch more decimals after it. And in fact, anything that's not a perfect square that we square root is what's called an irrational number. And that means that it has a non-repeating decimal that goes on forever. Without our calculator trying to find this, apparently you can do it. You can probably do it more than one way, actually. But it's not actually something that we really do anymore. Typically, these days, either we are allowed to use a calculator and we'll find it on our calculator as a decimal, or instead we just try to make it the simplest radical as possible. And that's something that we'll do later on this year in pre-algebra, as we'll talk about how to simplify square roots like this. But I do want us to explore the idea of, well, how could we estimate a square root? Maybe we don't use our calculator to find the square root, but how could we estimate it? That's what my example 3 here is going to be. It asks what two numbers are each of the following between. So in this case, our idea would be, okay, 20 is not a perfect square, but it's in between two numbers that are perfect squares. 16 and 25 are perfect squares, and 20 is almost smack dab in the middle of those two. So that means that square root of 20 is somewhere in between the square root of 16, which is 4, and the square root of 25, which is 5. So I don't know off the top of my head what the square root of 20 is as a decimal, but I know it has to be something between 4 and 5. I just thought this was kind of a fun thing to explore, so we're just going to do this on these next few. So square root of 42, what two square roots would this be in between? Let's see. Underneath 42 would be 36. Above 42 would be 49. And so that means this would be between 6 and 7. Square root of 11 would be between square root of 9 and square root of 16. So this would be between 3 and 4. And then square root of 91 is between square root of 81 and square root of 100. So between 9 and 10. Okay, so that's a way that we could estimate. We could even go further and say, well, I think it's like 9.4 or something, if we really wanted to, based on how close it is to each of the two perfect squares. But that gives you an idea of how we could at least estimate. There's one more thing I want to talk about, and basically we've been dealing with negative numbers in pre-algebra. That's kind of been our thing so far. And so we haven't had anything with negative numbers this whole lesson. So I want to mention why that is, and also what do we do with negatives, that kind of thing. So there's kind of two sides to this actually. First off, we said that we had a square root of 25 at the very beginning because we know that 5 times 5 equals 25, right? So the square root of 25 equals a positive 5. But there is actually something else that works. You might have thought about this earlier and wondered why I didn't mention it. Here I am mentioning it. What times what gives us 25? That's not positive 5 times positive 5. How about negative 5 times negative 5? Does that give me positive 25? Well, yeah, it does. So that means that the square root of 25 can also equal negative 5. So how do we know which one is intended? There's kind of two answers to this. One is that once we get into algebra, especially, we try not to assume. If there's a situation where we decide as the math person to take the square root in the problem, we put both answers. So that's part of it. If we are choosing, hey, I'm going to square root this in the process of solving an equation or something, we put plus and minus whatever the square root is. The other side to this, though, is a notation thing. So when a textbook or mathematician writes square root of 25, they actually are trying to tell you, I mean positive 5. This is I believe this is a mostly accepted thing, if not completely accepted, that when they write the square root symbol, they mean, yes, positive 5. Because if they wanted us to think negative 5, they'd put a negative in front of our radical. So negative square root of 25, you'd square root 25 and get 5, but the negative in front tells you it's negative. So this is a case where, hey, they've got the square root symbol in the book, and so we have to assume that if they wanted us to think it was negative, that they would put a negative in front of it. And there's algebraic and graphical reasons for that that we'll get into in Algebra 1. The other thing I want to talk about, though, is what about if getting a negative 25? Can I square root negative 25 and get an answer? What times what gives me negative 25 where it's the same thing both times? Okay, I can't actually answer both of those questions. I can answer one or the other, but not both with a situation. I can answer what times what gives me negative 25 with a positive 5 and a negative 5. But that's not the same number twice. If one of them's positive and one of them's negative, then I haven't found something squared. Okay, I can't write that as something squared. So for now, and for a little bit into our future, when we see square root of a negative number where the negative's under the square root, we're gonna say something to the effect of not possible. Now it's actually, it's math, right? So of course it's more complicated than that. It's actually more complicated than that. There is an answer to the square root of a negative number, but we save that for later because we don't want to just overload you with everything all at the same time. So that is something that you'll explore in Algebra 2, and it's a pretty fun time whenever we do explore it. But for now, at least, if you see square root of a negative number, you're going to say, can't do that because what we know thus far, it doesn't work. Thanks so much for watching. I hope that you enjoyed it. If you have any questions, feel free to leave me a comment, or if you actually are a student in my class, you know, there are other ways to communicate with teachers. But by all means, leave a comment, like, subscribe. I'm very, very excited that people are actually watching my videos. Maybe not this one. If you are, let me know. But lots of people watching my videos, and it's super duper cool. So thanks for that. Have a great day.